Alright, so for example 3, in this case especially, it's good to know your identities before you multiply. So if you know your identities, we're going to simplify the left side. Well, we do know that your secant squared x is equal to a tangent squared x plus 1. So what we're going to have to do is we can substitute secant squared x in this set of parentheses, and we also know that since the sine squared x plus cosine squared x equals 1, then what you can do is you just have to move the sine squared x to the right and then move the negative 1 to the left. So subtract 1 to both sides, every equal sign. Then you can also subtract sine squared x to both sides. So these cancel here, these cancel, and you end up getting a cosine squared x minus 1 equals negative sine squared x. So once again, we're just applying your identities, and so what we can do is we can take out the cosine squared x minus 1 and plug in negative sine squared x. So that gives us a secant squared x times a negative sine squared x, and we're still trying to simplify this so we can get a negative tangent squared x. So if you flip your secant squared x, that's equal to a 1 over cosine squared x, and then we're still going to leave this as a negative sine squared x. So what you get on the left, if this is over 1, you can multiply these together. You can have a negative sine squared x all over a cosine squared x, which is equal to a negative tangent squared x. So if we have our negative sine squared x over cosine squared x, if that's equal to a negative tangent squared x, we know that a sine over a cosine on the left here is going to turn this into a tangent. So this is going to be a negative tangent squared x on the left, which will be equal to a negative tangent squared x on the right. So that is your how to simplify problem number 3. If you come up with different ideas, please feel free to share those with the rest of the class as well.